Hi everyone, welcome to Meetings Technologies. Today's discussion will be on decorators, the most important advanced Python concept where most of people and a lot of my candidates try to understand about decorators and they come back to me with a lot of questions. So I thought of making it much clearer with this particular video about decorators. So when we say decorators, decorator is building something on top of existing functionality. Let me say for an example, we have a strawberry, right? I'll go to a pastry shop, okay, where we sell a lot of cakes and so, right? I'll just say as I need a strawberry, okay, I need a strawberry, as in this is strawberry, whatever, okay. So when you go to a pastry shop and they say that I need a strawberry, okay, so do you mean to say that you are asking for a strawberry as a fruit? No, right? When you say you go to a pastry shop and ask for a strawberry, you mean to say that you are looking for a strawberry cake. Similarly, you say that you require pineapple. Doesn't mean to say that you're looking pineapple as a fruit, right? You're looking for a pineapple as a flavor, as a pineapple pastry or whatever is it. That is, there is some existing functionality on top of which something else is happening in the backend. This is called as decorator in a high level. If you want to make it better understandable way, I can say one more example where you're saying something like I want to compute. I say something like compute. When you say is compute, automatically the computation is happening. Which computation? It can be addition, or it can be subtraction, it can be multiplication, it can be division. That is dynamic. On top of existing functionality, you are trying to do something else, is known as decorator. In simple, decorator is giving some flavor on top of existing functionality. As the name says, decorator, right? When I say it is decorator, decorator as the name says, decorating something. For example, which looks very plain. Okay, which looks very plain. When I say plain cake, right? So it's look very plain. Okay, that doesn't have any stuffing on top of it. But when I put some strawberries, okay, when I put some chilies on top of it, it looks very elegant. Okay, and is also doing some other functionalities where on top of plain cake you have some flavor where you can enjoy it. That is called as decorator. Okay, so decorators in a better way, if you want to understand it, on top of existing functionality, we try to do something else. This is called as decorator. In Python programming, this is an advanced Python concept, if you can say. This decorator is used in quite a lot of cases where you actually do some functionality. On top of it, you do something else along with that. To understand in a better way, let's go for practicals so that you understand. Okay. Before actually going to understand about decorators, right? So before understanding something all about decorators, we need to understand how functions can be used in different way in Python. Functions can be used as variables in Python. I repeat, functions can be used as a variable, right? Functions can be used as a variable, and functions can be used as arguments, right? Can be used as variables. Functions can be used as arguments, right? I just complete this as a variables. Functions can be used as arguments, very important, right? And we can create function inside a function, inner function. Functions can be used as arguments also, and we can create function inside a function, which we call it as an inner function. This is also possible, right? So before understanding much about decorators, let us try to understand how to work on all these individual concepts in Python, right? Okay, so made to understand better, let's directly jump to practical so that we get a better understanding, right? So if I can go to practical sessions, so this is all. I just really want to thank Kruti Vaja because I felt really very interesting of his documentation and it was really helping me. Okay, and it was in Medium, right? So when we say with decorators, okay, decorators are nothing but functions that add new functionality to the existing methods without changing them. Correct. Without changing the existing functionality, if we try to add new functionality, it is all about decorators, right? To understand decorators, you need to understand functions in Python. Correct. To understand about decorators, you need to understand functions in Python. As of now, I know very well that you people would have understood better about what is functions and how to work with functions, how to define different type of functions, and so on and so. Correct. Okay. And functions are class object. It is okay. So mean to say the functions are class objects. Python functions are class objects. It is we can assign multiple variables to same function. We can send them as an argument. We'll understand it practically. Here we have something called as d of function. Okay, we know very well how to define a function, d of function, and a passing a parameter x, right? And the function does a very simple operation, that is return x dot upper. That is, if whatever the argument you pass, we'll return the uppercase of the same. So whatever the func is there here, right, that I'm assigning to a variable called as f2, right? So one thing you need to understand, that functions can be given to a variable. Important point to be noted. Function can be given as a variable. Func is a function that I'm giving to a variable called f2, and I can pass argument for f2, that is neon, right? Neow. So what happens is it is converted to the uppercase and output is displayed, right? Now if I delete the original functionality, delete func, right? We delete func, even then the f2 exists. Mean to say that you're not just copying the reference of func to f2. Guys, very important to understand. You're not just copying the reference of func to f2, rather you're creating a new function called as f2. That is, the complete code of a func is being copied to f2. That is, even though I delete func, right? Even though I delete func here, I just execute it once again for you. Delete func has been done, but f2 of bark is been converted to uppercase. Mean to say that whatever the functionality which was happening with func, the same is happening given with f2. Very important to understand, right? So one point to clear as of now with functions is functions can be assigned to variables. Point number one to be clear. Now create function inside a function. We can create function inside a function. This is just for your understanding. That is, we have a factorial program here. If type of n is equal to int and n is greater than or equal to 0, that is, we are checking whether the data type of n is integer, because n is an argument what we are passing here. Okay, and if n equal to 0, return 1. If n is equal to 0, then factorial of 0 is 1, right? Don't say 0, please. Okay, factorial of 0 is actually 1. So if you say n equal to 0, then I say return 1. Else we say return n into factorial of n minus 1. This is a recursive program, right? How come it's recursive program? We keep on recurring, we keep on repeating n into factorial of n minus 1. So if you ask me how this would happen, it is something like this, where I can say in a very clear way, right? If you pass 5, right, 5 factorial, we can say 5 into, okay, fact of 4. Okay, fact of 4 internally calls fact of 3. Fact of 3 internally calls fact of 2. Fact of 2 internally calls fact of 1. That is, it is like a recursive program which keeps on calling one after the other, right? See, n into factorial of n minus 1. It keeps on repeating. But the problem with this is, every time whenever you call this factorial program, right, it keeps on checking whether n is integer. For example, you pass the factorial of 5. Okay, if you pass factorial of 5, it checks whether 5 is integer. It checks whether 4 is integer. It checks whether 3 is integer. 2 is integer. That is what the code is written, right? If you can check here. Okay, type of n is equal to int. Type of n, every time it keeps on checking. Factorial of 10, in this case, of course, it is checking 10 times whether it is an integer. So is there any better way to handle it? Guys, I want you to understand it's nothing to do with the functionality, because with all our other sessions, we have understood how to write a factorial program. Okay, I want you people to understand it in a better way here, so that you don't get messed up with internal functions, or I can say inner functions. Okay, recursive call is one of the topic, if we can say in a better way. Recursive call, factorial of n minus 1, right? Okay, what is factorial of n minus 1? If I pass factorial of 10, then what happens? It checks if type of 10 is equal to integer. Yes. Is 10 greater than or equal to 0? Yes. Now what I do is return n into factorial of n minus 1. What is n? N is 10. 10 into factorial of 9. Oh, when you call factorial of 9, then what happens? It goes back here. Then it checks what is n now. N is 9. 9 is equal to int. Correct. 9 is greater than or equal to 0. Correct. So n is equal to 0. No. Again come 8 into factorial of n minus 1. So 9 into factorial of 8. Then factorial of 8 is passed. Then 8 into factorial of 7. It keeps on repeating, right? It keeps on repeating. Finally, it will be the factorial of 10. So this is the scenario, right? So it happens. Now, to check, as I told you, each and every time we are checking whether n is integer. Is there a better way of doing it? Yes, Python gives you a better way called as internal functions, or called as inner functions. If you ask me how, right? Factorial of n is passed, then I write inner factorial. Here what I do is, I just check once, okay, just check once whether the type of n is equal to int, right? Type of number is equal to int. If it is true, then I'll call inner factorial of n. This inner factorial of n repeatedly does, okay, it does internally. So no need of every time checking whether n is integer. Don't keep on checking that n is integer, is n is integer, no, not required. Okay, once I'll give 10. If 10 is integer, done. Then what I do return inner factorial of n. What is inner factorial of 10? Inner factorial of 10 internally pass n into inner factorial of what? Inner factorial of 9. Then inner factorial of 8. Inner factorial of 7. It keeps on repeating. This is called as recursive functions. right? Function which keeps on happening again, it is called a recursive function, and we can solve it in a better way using inner functions in Python. That is, function inside a function is called as inner function. So 2 points what we need to understand before going to decorators here is, case number 1, that functions can be given to a variable. Case number 2, functions can be passed as an argument, that we will see, and in a better way we can say that function can be defined inside a function called as inner functions, which we understood in a better way. Then we can pass function as an argument, right, in a parameter. What is that function as a parameter? For example, here we have sine cos. So the function is a sine cos, and expecting an argument called as func and var, right? So what I do here is I call sine cos and I call math.sin of 60, right? So this is like, what happens here is I am calling sine cos, okay? Internally sine cos I am passing math.sin. This math.sin is actually a function. Guys, I want you to understand. Okay, math.sin is a function where I'm passing it and it is stored in func. Internally, I'm passing 60. So math.sin of 60, that is sine theta of 60, is your actual output. Right? This is what I understand. That is, in Python, we can understand that function names can be passed as an argument. This was the scenario here. Function names can be passed as an arguments. Here function name is math.sin. That math.sin can be passed as an argument. The better understanding what we can give. Right? So 3 scenarios. Internal function, inner functions can be done. Then it is something called as function can be created as variables. Then what? Function can be passed as an arguments. Super. So these are the 3 different points. Last point is functions can return other functions. What do you mean by this? This sounds very interesting. Okay, def sound of range. Okay, so here I am creating one more function inside it. So inner function, loud of x. Okay, print h dot upper. Okay, print low h dot lower. Okay, if range equal to loud, return loud. If else, return low. What do you mean by this? I mean to say here we are creating one function called as sound. In sound, I am passing an argument called as loud. Understand? In sound, I am passing an argument called as round. Here I am checking here whether the range what I have got is equal to loud, right? I'm returning loud. Where is loud? Loud is nothing but a function. Loud is nothing but a function, guys. Okay, I'm returning loud. When I say return loud, what happens? Print x dot upper, and you'll be getting a something called as lion or tiger, whatever. Okay, roar. Okay, if the low, then it is cat. Very important to understand. That is, here we are returning function as a return type. Function can return other functions. Very important to understand. Function can return other functions. See, this is something which is very special to Python perspective. There are 4 points. Before understanding decorator, yes, but these are the very important principles which has to be learned in Python perspective. Okay, I keep on repeating once again. Okay, so that people will keep this in mind. The first point here is assign the function to multiple variables. That is, function names can be assigned as a variable. Case number 2. Create function inside a function. That is, we can create function inside one more function. Correct? Internal functions. Then case 3, pass function as a parameter to the function. We can pass the function as an argument. Okay? Case number 4, function can return other functions. We can return the data type. Okay, just like how we return the data type, we can return the functions. These are the 4 important points. Before going to decorators, you need to understand that, right? So if we can just run this, okay, I'll take this one more time. We have created a sound function. Okay, inside that sound function, we have 2 functions defined. So inner function, loud and low are inner functions, and I'll see the range. If range is equal to loud, then I return loud. So here loud is nowhere a data type, it's a function name. The function name. I'm returning loud means to say automatically this loud is returned and it is executed. See, I'm passing sound, okay, loud, and I'm catching inside a variable called as tiger. Okay, I'm returning loud mean to say you are returning a function name. So function names can be the return type, guys. That's what I want to understand. I'm catching inside tiger. For tiger, I'm passing road, right? So when I say tiger of road, then what happens? Then what happens is internally, okay, the loud with respect to road is being given, right? So this is very really very interesting. This can be handled in a better way, guys. Okay, better way in terms of if we can see this. Okay, actual functionality sound, internally sound is calling loud. That is, on top of existing functionality, you are doing something else. This can be done in a better way with respect to decorators. This is what I wanted you people to conclude with functions, right? That is, with respect to
existing functionality, you're trying to do something on top of it. It makes sound okay. What kind of sound? Loud or low? That is, sound is a function. Inside that, there's something else is happening. This is called as decorator.